So we have been working, we have started with bash scripting. We started to build a simple script, which is about reading displaying a report about with some information about the system. So let's open this script and see what we have done. So this is the shebang, and it is telling the system that it should use this program to interpret this script or to execute this script. This is starting a comment, and this is a comment program to output a system information page. So this is what this program is doing, or this script is doing. And here we declare a constant, declare read-only, and then here is a name of the variable, system information report for host name. So this host name is a system environment variable. So it is an environment variable. It is already defined when we log into the bash shell. And we have here another variable, current time, which we get the value from the command date. So we execute the command date and assign the output of the command to this variable. And we are building this variable timestamp generated on current time by user. This current time with $sign in front is getting the value of this variable. And this user is again environment variable. It contains the username of the current user that is logged in to the system. And here we have an echo, open the string and close the string here. So it is possible to have new line characters inside the string. And here we have these variables that we have defined above, title and timestamp. Now, instead of echo, I want to use a here document. And let me show it first and then explain it later. So I will first, I will go to the line that contains echo by pressing this slash and then typing echo and then enter. And here I will open a new line above with uppercase O, open a new line above this one. And I will type the cut command and a file. And then let me go to the last line, which is with capital G. And let me open a new line under this one with lowercase o. And here I'm closing this. So here is a token and the beginning of input. And here is the same token on a single line with no other things on the line at the beginning of the line. It is closing the input, and everything in between is considered as an input to this command. So this construct is called a here document. So it is another way of redirecting output. So so in this case, it is redirecting the standard input of the command cut. So the command cut in this case is taking the input from these lines up until to the closing token. Now I want to delete this echo and also this closing quotation mark that is closing the string. So let me go again to the line that contains echo with slash and echo, and then escape slash echo, and then enter. And with D and W, I'm going to delete this word, and then with an X, I'm going to delete this character under the cursor. Now let me go to the last line with capital G, go to the last line, and then one line above with, no, it is with K, and then go to the end of the line with $, and now I press an X to delete this character. Now I'm done. Let me save and test this script. So it is work all the same. So here document, as I told, is to redirect the standard input of a command. Let me try another example that contains some variables. But first, let me define a variable. Now I'm redirecting, and then I'll try this, and then let me try with double quotes, and then with single quotes, and then by escaping the $, and then the token that is not denoting the end of input in this case. So we see that the variables are expanded by the shell. So this $foo has been replaced by its value, and also the other cases of variables, except for this one where we escape the $, with this slash character. One of the benefits of here document is that it can contain quotation marks. So we can use quotation marks without problem inside the text that we are using. So if we use a string with which starts and which is delimited by double quotes, we can use single quotes inside, but not double quotes. It is very difficult to use double quotes inside, and vice versa. If we have a string that is delimited by single quotes, inside this string we can freely use double quotes, but we cannot use single quotes. But if we have, in case that we have a here document, we can use double quotes and single quotes as much as we want without a problem. So this is one of the advantages of using here document instead of using a string like this that we had before, echo and then output something. Now, if we want to prevent the expansion of variables in the text that is given as input, we can, so I use the up arrow to recall the previous command, and then Control A to go to the beginning. We can surround this token with quotation marks. So if I surround it with quotation marks, then this will prevent the shell from expanding the variables inside this text. And the same happens also with single quotation marks. So if I surround it with single quotation marks, again, the shell is not going to expand or to replace the variables in the input. Now let's see some other examples with this here document. It can be used with other commands as well. For example, in this script, we are using the FTP command to connect to a remote server, and the remote server is this one. It is an FTP server, FTP means File Transfer Protocol. It is a protocol that is used to transfer files between two computers in internet, either to download a file or to upload a file somewhere. And in this variable FTP path is the directory where the file that we want to download is located. And in the variable remote file is the name of the file. And now I start the command FTP, or we call the command FTP in the script, and we are redirecting the standard input of that command, so that it is going to read the commands until this token. So all these lines will be fetched to this program as commands, one by one. Each line one command. The first command, open, is contacting the server, the given FTP server, and it is creating a connection with it. And then the command user, anonymous, and an email address is authenticating a user. And in this case, we are authenticating as anonymous user. Some FTP servers accept it, but not all of them. But in this case, this server does accept anonymous login. So we are authenticating as an anonymous user. And then the command cd is an FTP command. With this command, we are going to the directory where the file that we want to download is located. And then the command get is downloading this file to the current directory. And then bye is closing the connection with the server. We exit from the FTP server. And then the next command, we just list the file that is downloaded to make sure that it worked, to make sure that these commands work. So let's test this. So it connected to the server, and then so it did a login successful, and then it changed the directory. The directory successfully changed because we don't see the commands; we just see the output, the reply from the server. And then here it is downloading the file. It says transfer complete. And then I say bye, I give the command bye, and I get the reply from the server, goodbye. And this is the output of the last command of the script, which shows that the file has been downloaded. So here is the file that we downloaded with this script. Let's clean up, remove it. Now, a similar script is this one, but with a small modification. So the modification is that we are appending this dash or this minus sign after the redirection operator. And this allows us to prefix each line with a tab. So this is not actually spaces, these are tab. And also we prefix the closing token with a tab, with one or more tabs. Because what this does is it ignores the preceding tabs. And the result is that this is more readable. So we understand that we can understand easily that these are commands for FTP. And then this is another command in the script. This is not related to the FTP command. So it makes the script more readable. This is the benefit of using this. So let's try this FTP2 again. And we see that it works too, the same. Now we will see shell functions. And before explaining them, let's see this example script. Here we have the definition of a function. We start with this keyword function, and then this is the name of the function. And then this parentheses may contain arguments, but usually they are empty. And then a curly brace, opening curly brace, and then closing curly brace. And here are the commands or the body of the function. Actually, this keyword function is optional. Even if we omit it, shell will be able to understand that here we are defining a function. And here starts the main body of the program. We have the command echo, which is displaying this string, step 1, and then we are calling the function by its name, step 2, and this function just displays this string, step 2, and then return is closing the function. And finally, this command is executed, step 3. So let's test it. So this is the output displayed by the function, and this is displayed by the first echo, and this is displayed by the last echo. Inside a function, we can use local variables, and let's see this example for this script as an example. So again, we are defining this function with the name funct_1. We are not using the keyword function, but it doesn't matter. It is all the same. The shell is able to understand that this is a function definition. We are defining a function here. And here there is another function with the name funct_2. And here, actually, here we are defining a local variable named foo. And here, this is a global variable with the same name, foo. The global variable gets the value 0. Inside the function 1, we are giving the variable foo the value 1. But actually, because this is a local variable, this is a different variable from the global one. So when we assign the value 1 to this variable foo, it does not modify the value of the global variable. And the same for the second function. We are declaring a local variable foo, and we are assigning it the number 2 as a value. But this assignment does not change the does not change the value of the global variable. Because the local variable is it is a different variable from the local from the global one, although they have the same name. They have the same name, but they live in different scopes. So the scope of this variable is from this curly brace up to this curly brace. And when the function is executed, after the function is done, then this variable does not exist anymore. And at the end, this is the main body of the script or the program. We show the value of the global variable. We call the function 1, which is changing the local variable. And then we show again the value of the global variable. We call the function 2 and show again the value of the global variable. So we are testing that local variables are different from global ones. And when we change the value of a local variable, it does not modify the value of the global one. So let's execute it. So the global variable has value 0. The local one has value 1. But the global is still unmodified. It is still 0. And when we call the function 2, the second function, the local variable has the value 2, but the global variable still is unmodified. It has the value 0. So if I modify this script, and instead of declaring a local variable, I use the global one, so I'm making this comment. So in this case, this variable foo is the global one. So we are modifying the value of the global variable. And let me comment this one as well. The result will be different. So it has value 0 initially. After the first function is executed, it has the value 1. And after the function, it keeps the value 1, because the value that was modified inside the function is the global variable. And the same, when the function 2 is executed, the variable foo gets the value 2. And it is actually the global variable, so when we check the value after the function is done, the value is modified. Now let's use these some functions to elaborate further this script, system information shell, so that it can display some real information about the system. We'll use some functions to get the value that is going to be displayed. But first, let's create some functions inside this script. So let me go to the line cut, and then I open a new line there, and then I declare some functions. These functions, for the time being, are doing nothing. They do nothing, just return and do nothing. We will improve them later so that they actually do some useful thing. But now let me call these functions here. So here we see an example of shell expansion because it is starting with $, and there are these parentheses. So what happens is that the shell is going to execute this function, and the output of the function, the output that is coming from this function, will be placed here. So all this will be replaced by the output of the function. So let's test this one. And actually, we see some empty lines because all the functions don't do anything yet. Let's modify these functions so that they do something more useful. Here, and escape to go to the command line mode. And then I'm going to copy this line with capital Y. So with capital Y, I'm copying this line, young. Now let me go to this function, and with lowercase p, I'm pasting the buffer, and let me just modify the string of echo report disk space. Oops. Escape again, and then here with p, paste the content of the buffer again. With I, go to insert mode, and then modify. Escape, right, and quit. And let's test it again. And we see that here we get the output from the first function. Here is the output of the second function, and here is the output of the third function. And in order to get some useful output, actually, for the report, we are going to use some commands. For example, the command uptime is showing some information about the system, which says up for 2 days. There are 3 users, load average, and so on. So we want to output this, to get this output from the first function, report uptime here. So let me modify this Vim. Okay. Let me modify this function report uptime. Okay. I'm going to delete these 2 lines with 2 and DD, double D, 2 double D, and then capital O to open a new line. And then I'm going to use the command cut to output something. And let me use this as a token. And I'm using the tab here to move, and then let me close this token. And then tab again. This will be the header. And here I'm going to get the output from the command uptime. So, but let me surround this with pre-formatted tags. So this function is actually outputting a piece of HTML, which contains 2 lines. This is one header of second level, and this is a pre-formatted text, which actually displays the output of the command uptime. So let me save this, and let me test. So here I'm getting these 2 lines from the first function. And in order to get disk space and home space, I can use these commands, dfh, and disk usage. So I can use these 2 commands to display the disk space information and home space information. So let me start editing the script again. Let me copy these 4 lines. For young, capital Y. And let me paste them here. Paste. And then let me delete these 2 lines to PD. And let me modify, or let me do this pasting again here. No. For young again. And then paste. And then to DD. And now the header or the title should be this space utilization. Utilization. And the command actually that gives this information is and here the title will be home space utilization. And the command that is going to generate the output is going to be disk usage, HS, and then home. So let me write first and then quit and then test. So here is the output of the second function. And here is the output of the third function. And let me save this to the output from this command to the HTML file. And let me check with Linux. So here is the title, and here is the timestamp. And then the output of the first function, system uptime, the output of the second function, disk space utilization, and the output of the third function, home space utilization. Exit. Now we will start another lesson, which is related to branching with the command if. But before we do this, let's download some example scripts that we are going to use in this lesson. And we can download them with the command wget https examples and we can extract this archive with the command tar extract. It is compressed, so we are using this Z, and then F is the file of the archive, which is this lesson 11.tgz. And the example scripts are in this directory, lesson 11. So here they are. But before we start with the command if, first of all, we should know that each command in Linux has an exit status or returns an exit status. And the exit status of a command shows whether it was finished successfully or there was some error during the execution of the command. If the command is executed successfully, the exit status is 0. 0 means successful execution. If there was some error, then the exit status is a number different from 0, and it may depend on the kind of error. For example, for some kind of error, it may return 1. Some other types of error, it may return 2. And so the error that it returns also indicates what kind of thing went wrong, what was the problem. So let me try a successful command. So this is a command. It was executed successfully. And now let me see the value of this variable. This is a special variable, and it always contains the exit status of the last command. The last command that was executed by the shell was this one. So this contains the exit status of the last command. And the exit status of the last command is 0, which means the command was executed successfully. Now, if the command, let's try another command, for example, we see that this command is not executed successfully because it displays an error message. But let's check the exit status. And the exit status is 2, something different from 0, which indicates that there was some errors or there were some problems during the execution of this command. And there are two special commands in Linux which are called true and false, which actually do nothing, but they return an exit status. The command true returns an exit status of 0, successful. And the command false returns an exit status of 1, which means not successful. And we can use them in scripts and in other commands. But let's see how we can use it with the command if. If true, then echo it is true. Okay. So we start the if with if, and we close it with phi, which is if in reverse. Here are the commands that are executed. There may be more than one command. If these commands are successful, then the part after the commands after then are executed. So this true is the command that is executed successfully. So the command then is the command after then is executed, and it is displayed. It is displaying it is true. But if this is false, false returns exit status different from 0. So this command fails, indicates failure. Then the part of the scripts after then are not executed. So the command after then is not executed. And here, the condition after if can be composed of more than one commands. So we may have more than one commands. For example, if true, false, then echo it is true. And let's see what's happened. Now the exit status that is checked by if is the exit status of the last command. So if we have several commands separated by semicolon, only the exit status of the last command is checked by if. And in this case, we have false as the last command. So it is a failure. This is not executed. If it was, for example, if true, false, true. Now we have 3 commands that are executed, but the last one is executed successfully. So the part after them is executed. with the command if, usually we use the command test, and test is used to do some logical testing or to check some attributes of files. Do they exist? Are they executable? Are they readable? And so on. So first, let's create an empty file. That we can use for testing. Now let's write this if command, if test -e foo.text, then echo file exists, and then we close it with fee. So this option -e is checking whether this file exists or not. Since the file exists, because we just created it, it is running this command, echo file exists. But let's try it with, for example, file foo1.txt. This file does not exist, so this command is returning failure, and so the command after then is not executed. Actually, the command test can be used in another format. So we can use this construct instead of test, and they are equivalent. So this command here can also be written in this form. So we see instead of test, we are using this square bracket, and then we also have to end it to close it with a closing square bracket. And actually, these two are equivalent. These are like the same command, but with two different names. And let's actually also see another. Besides then, we can have else as well. So if can contain a then part and an else part. So we have if, we have the testing part. If the test is successful, the command after then is executed. If the test is not successful, the command after else is executed. So if we try the same command with a file that does not exist, then actually the command after else is executed. So if the test is successful, if the commands here are executed successfully, then the commands after then are executed. If these fail, then the commands after else are executed. Let's see an example file that is using some is using a command test to check for the properties of some files. So we have a variable file which gets the name of a file. This file actually exists. This is the home directory. This tilde always is replaced by the home directory, by the shell. It is expanded by the shell. And here we have a bunch of tests. So the first test is if the file exists or not. If the file exists, then we are doing some other tests here. But if the file does not exist, then we are displaying this message: file does not exist, and then we exit from the script with exit value 1. So this command exit is terminating the script, but it can also take a number as an exit value. And the exit value 1 is indicating that there was an error. Because the file does not exist, we are returning an error. And here at the end of the script, we have exit without a number, without an exit code. And by default, the exit code is 0. If no number is given, then it is 0, which means success. The script was executed successfully. And if the file exists, we have some other testing. This -f is testing whether the file is a regular file. -d is testing whether the given file is actually a directory. -r is testing whether the file is readable by the user that is executing this script. And the option -w is checking whether the file is writable, has the right permission for the user that is executing this script. And -x is checking whether the file is executable or searchable, because the option -x means executable for files, but it means it is searchable for directories. If it is a directory and it has the option -x, it means that it can be searched. It is a searchable directory. And notice also that we are enclosing this with double quotes. And it is used as a precaution in case that this file contains some empty spaces, or if the file itself is not defined. It is if this variable file is not defined, it is empty. If it is empty, then it will break the structure of the script, and the script will return a syntax error. Or if the name of the file contains some empty space, again, the script will be broken and it will return some syntax errors. And so for this reason, we are using these double quotes surrounding the variable. But if we know for sure that these cases are not possible, then we can omit. We may not use these double quotes. So let me check. Let me execute this script. And this file is a regular file. It is readable. It is writable. Let's see another file. For example, we can use the file test file itself. So we are checking for this file itself. It is checking its own itself. It is checking itself. So it is a regular file. It is readable. It is writable. It is executable. Let's try with a directory. For example, we have the directory examples on the home directory. And if we test the script, then we get the message: it is a directory, it is readable, it is writable, it is searchable. And let's try, for example, with something that does not exist. And we get the message non-existent file that does not exist. And if we check the return or the exit code of the last command, sorry, let's try again. we see that we get this exit code 1, which is the value that is returned by this command here, and it indicates that there was some error or there was some problem with the script. Now the same test, the same kind of testing that we did with this script can also done inside a function. So let's check this other example script. So it is almost the same thing, except that everything, all the testing is included inside this function test file, and at the end of the script, we are calling this function test file. But there is a small thing different from the first thing, from the first script, that inside the function, when we are inside the function, is instead of exit, we use return to exit from this function, because if we use exit, it is exiting from the script, from the entire script. But if we just want to exit from the function, then we use return. And again, we can pass a number as an argument to the command return, and this will be the exit code of this command when it is executed, when it is called here. And this script does not have an exit code, but the exit code of the last command is the exit code of the entire script. And the rest of the testing is the same. We check whether the file exists or not. It is a regular file. Is it a directory? Is it readable? Is it writable? Is it executable? So let us try it. And it is checking this file again. And we can modify the file, for example, with directory. And now it is detecting that it is a directory. And the script has terminated normally with success. But if we use some file or directory that does not exist, and we try to execute the script, then we get the message does not exist. And in this case, it is returning exit code 1, which means something went wrong, something was not executed properly. The script was not executed properly. Now let's see another example script that is testing some strings. It is making some tests about the strings. So so far we have been testing for the files and directories. Do they exist? And what properties they have? Are they readable, writable, etc.? But we can also test strings. And we have this variable answer, and right now it has the value maybe. And with this option -z, we are checking whether this variable is empty or not. Is it empty or zero length? For example, we can think of it, it is zero length. And if the variable is empty, has no value, then we display the message there is no answer, and return with exit code 1. We exit with the code 1, which means error. But the message that we display actually is redirected to standard error. So we display this message to the standard error, not to the standard output, because it is an error message. And usually a script or a command, when they display an error message, they should send it to the standard error, not to standard output. This is good practice. And here we are testing whether the value of variable answer is equal to yes. And if so, then we display the answer is yes. Here we have an elif. Elif is else if. Else if we are testing something else. So if this test is failing, then we are making another test. And if this test is also failing, with elif we are making another test. If answer is equal to maybe. And then finally we say else. If all the testing above failed, then we use the answer is we use this part. This part will be executed. The answer is unknown. So let's check it. The answer is maybe. And if I modify it, and try it again, the answer is yes. And let's say that the answer is unknown. And now suppose that the answer is empty, like this. Now we get the answer, there is no answer. And actually we get an error, exit code of 1. And this also happens if the variable is undefined. So the variable answer is not defined at all. Again, we will get the error message, there is no answer. The script test integer is similar to the scripts that we have seen so far, but it is testing some integer values. So we have been testing files, do they exist or not? We have been testing strings, are they equal to something or not? Or are they empty, do they exist? And we can also test integer values. So we have this int variable, which has the value -5. And again, we are checking whether the variable is valid with this -z. So if the variable integer has no value or is not defined, then this -z is checking this case. And the script is displaying an error message, and it is sending it to standard error. It is redirecting. This is a redirect of standard output to standard error. So the command echo by default is displaying something to the standard output. But in this case, we are redirecting the standard output of this command to standard error. So this message will actually be displayed to standard error as an error message. And we'll also exit with some value different from 0. And the rest of the script is checking the variable int for different values. If it is equal to 0, so this means equal. This is a test that means equal for integers. It is used for integers, not for strings. For strings, we use an equal sign to check whether a string is whether two strings are equal. For integers, we use this minus equal. Then echo integer is 0. Else, if the integer is not 0, then we are testing is it less than 0. So minus LT means less than. If it is less than 0, we display the message it is negative. Otherwise, we display integer is positive. Then another test here. We get the remainder of dividing by 2 and check whether it is equal to 0. So the remainder of division by 2 is equal to 0. If yes, then we display the message integer is even. Otherwise, we display the message integer is odd. And this is the script. Let's test it. Let's execute it. And it is saying integer is negative and integer is odd because the value of integer is minus 5. Let's say that the value of integer is 11. And we try the script again. Integer is positive, integer is odd. Now, let's make it, for example, 12. Integer is positive, integer is even. And if we make it 0, then we just get the message integer is 0. And if actually the integer is undefined or it has an empty value, it can also be undefined. Then we get the message integer is empty. And the exit code is different from 0. And actually, we are using these double quotes to prevent or for a case like this. For example, if integer is undefined. Without double quotes, then we would get a syntax error from this from this if, because when shell tries to replace this, it is going to replace it by an empty value, and then we will have here a broken syntax for the test command. So that's why we are using this double quotes. If we know for sure that this cannot be empty, this variable is always defined, then we may not use this double quotes surrounding the value of the variable. And the command test, help test. We can see the help of this command to see what other options are possible that we can use. For example, this minus a is used with a file, and it is used to check whether the file exists. And we have seen some of these options. But we can also use this newer than. If file 1 is newer than file 2, then the test will be successful or will succeed. This is older than, and we use this test minus z for a string, which is true if the string is empty. And we may use the opposite, minus n. Minus n is the opposite of minus z. And it is the string is true if the string is not empty. For two strings, we can compare them with the equal sign, whether they are equal, and this is different, whether they are not equal. And this less than and equal than are actually lexicographical comparison. So this is not for integers. This is used for strings. And for example, A is less than B because A is before B in the alphabet. This is a lexicographical comparison or lexicographical ordering. So let's also see this So the help for this says that this is a synonym for the test built-in, but the last argument must be a literal closing bracket to match the opening. So this is almost the same as the command test. So let's stop here for today, and we will continue in the next lesson with more examples about testing.